Hello everyone. Today I am going to discuss some more MCQs which will be very useful for you. At the end of your revision, you can go through them and test yourself. You can test your own knowledge. Okay? I have randomly selected some numericals and some theoretical questions also, which will be very useful to you and which are all also important. So let us start with the first one without wasting much time. The first question, if the conductor is stationary, then we can write Lorentz force as. We know the formula for Lorentz force. So Lorentz force is given by F bar is equal to QE bar plus Q V bar cross B bar. This is the Lorentz force. Now what they have said here, they said that when the conductor is stationary, so that means there is no velocity. When there is no velocity means this one, that is V is equal to 0. When V equal to 0, this product becomes 0. Therefore, F is equal to QE bar. So this is the answer. So this answer is given in C. So the answer is C. C is the answer. Okay. So now let's go for the second problem. The intensity of bright and dark fringes are 9I and I respectively. The ratio of amplitude of two waves is given by. The ratio of amplitude of two waves is given by. So let us take now what we can take is, they have given the ratio. So the ratio is I max to I min, that is maximum intensity, I max divided by I min, minimum, that is equal to 9 divided by 1. We all know intensity is directly proportional to amplitude square. Therefore, let us take A max, that is by A minimum. A max by A min is equal to 3 divided by 1. So, because here A square is equal to some constant into I, you can think like that. Therefore, A is equal to under root I. Therefore, root 9 is 3 and root 1 is 1. A max by A min is equal to 3 is to 1. Okay, so that is equal to A1 plus A2 divided by A1 minus A2. Therefore, you will get 3A1 minus A2 is equal to 1 into A1 plus A2. Then you will get now, that is 3A1 minus 3A2 is equal to A1 plus A2, which gives rise to, that is 2A1 is equal to 4A2. Therefore, A1 by A2 is equal to 4 by 2, which is equal to 2 by 1. So the answer is 2 is to 1. The answer is 2 is to 1. 2 is to 1 is given in option D. So the answer is D. Okay. So let's go for the third problem. The third problem goes like this. Two particles A1 and A2 of masses M1 and M2, where M1 is greater than M2, have the same de Broglie wavelength. Then 4 options they have given. Their momenta are the same, their energies are same. Energy of A1 is greater than the energy of A2. Momentum of A2 is more than momentum of A1. So that is what they have given here. So let us solve this problem. So what they have given here, there are two particles which are A1 and A2. We have to see now how we can solve them. Let us go and solve it now. I'll go little down and solve from here. Now if you can think lambda, de Broglie wavelength lambda is equal to h by p. Therefore p, that is momentum, is equal to h by lambda. H is Planck's constant, lambda is wavelength. So what we can conclude here, p is, that is momentum, is inversely proportional to wavelength. Therefore p1 by p2, that is ratio of the momenta of the two particles, p1 by p2 is equal to lambda 2 by lambda 1. Therefore what they have given in the problem, they have given in the problem that both of them have same de Broglie wavelength. That means lambda is the same. Therefore lambda by lambda, which gives rise to P1 is equal to P2, that is their momenta are the same. So the answer will be A. We will also check the energies and then we will come to the conclusion, because we cannot conclude immediately when momenta are same. Let us check for another also, that is energies also we will check. So let us take now that is P1 by P2 is equal to lambda 1 by lambda 2, which is lambda 2 by lambda 1, that is equal to P1 is equal to P2. Therefore which is equal to P1 is equal to P2. Momenta are same. Now coming to energy, E is equal to P square by 2m. We all know that. Then that is equal to H square by 2m, H square by 2m lambda square, since P is equal to H by lambda. Just now we have seen. Therefore we will get what we are going to get now. From this we can conclude that H is Planck's constant and even this lambda is same for both of them. Therefore E is inversely proportional to mass. Therefore we can conclude that E1 by E2 is equal to M2 by M1. E1 by E2 is equal to M2 by M1. Therefore in the problem they have given, what they have given, I'll go up and show you. M1 is greater than M2 they have given. When M1 is greater than M2, when M1 is greater than M2, so now here you can see they have given here E1 divided by, I have written here E1 by E2. E1 by E2 is equal to M2 by M1, but they have given in the problem M1 is greater than M2. Therefore we can conclude that E2 is greater than E1. Therefore energies are not the same. Energies are not same. So what is the conclusion now? We have momenta, that is P1 is equal to P2. What we have finally got here is this one, that is momenta P1 is equal to P2. So the correct answer is A. Their momenta are the same. Okay, then let's go for the next problem, that is the fourth problem. So I have taken only 10 problems. In most of the videos I am taking only 10 problems at a time, MCQs. Now let's go for the next one, that is a distance, fourth one, distance of closest approach to a gold nucleus of an alpha particle of kinetic energy 5.5 mega electron volts is about. Let us solve this problem now. Let's solve. Now E is equal to, we know energy of a system of two charges. We have done it in the second chapter, that is potential energy. We have seen the energy, there we have derived that expression. We know that energy is equal to QQ by 4 pi epsilon naught D, where Q is smaller charge. In this case it is alpha particle, capital Q is the gold one, gold charge on the gold one. Then after that gold nucleus, and after that we have D. D is the distance between them. Now we want D only. Take D to the left side and bring all others to right side. D is equal to QQ by 4 pi epsilon naught into E. 4 pi epsilon naught into E. Now let us see what are these values. Let us see small q, that is equal to alpha particle. Alpha particle means helium. Therefore, it has 2 electrons and 2 protons. The charge of the alpha particle is 2 of this charge of the electron. Then that is equal to 2 into E. That is equal to 2 into 1.6 into 10 to the power of minus 19 coulombs. Then let us see gold. Gold, we know atomic number of gold is 79. So charge on the gold nucleus, 79 into charge of the electron, that is 79 into 1.6 into 10 to the power of minus 19 coulombs. Now distance between them, they have distance, that only we have to find. So we have to find that one, but energy they have given. What is the energy they have given? That is E is equal to 5.5 mega electron volts they have given. So now let us take and substitute all these values in this formula. This one, then we get now, that is E is equal to Q by 4 pi epsilon naught D. From this already I told you small d is equal to QQ by 4 pi epsilon naught into E. Now I am going to substitute all these values here. One more thing is E is given in mega electron volts. So 5.5 mega means 10 to the power of 6. Electron volts, to convert into joules, 1.6 into 10 to the power of minus 19. We have to multiply with that. You will get in joules. And then after that, substitute all the values in this particular formula. This formula we are going to get D is equal to, that is Q, small q. So small q means here I have already written 2 into 1.6 into 10 to the power of minus 19. Capital Q, 79 into 1.6 into 10 to the power of minus 19. So let us substitute all the values for this equation of D. Then small q is equal to 2 into 1.6 into 10 to the power of minus 19. Capital Q, 79 into 1.6 into 10 to the power of minus 19. So 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught I am writing here 9 into 10 to the power of 9, and E value 5.5 into 10 to the power of 6 into 1.6 into 10 to the power of minus 19. Okay, so taking all these values. Okay, so once you calculate all these things, energy will become 8.8 into 10 to the power of minus 13. Then you will get, once you simplify all these values, you will get the value 413.67 into 10 to the power of minus 16. That is equal to, we should compare with the MCQs, 4.13 into 10 to the power of minus 14 meters. 4.13 into 10 to the power of minus 14 meters. So I will take you up what are the options they have given. Option A, 2 into 10 to the power of 10 minus 10. B, 3 into 10 to the power of minus 12. C, 4 into 10 to the power of minus 14 meters. So this is the answer now. So we have the answer C. Answer is C, 4 into 10 to the power of minus 14 meters. Okay, so now that is the answer. Let's go for the fifth problem. A light bulb is rated at 100 watts for a 300 volts supply. The peak voltage of the source is peak value. It is a simple problem, that not that much difficult. You can see the previous problem was little big for 1 mark, but it is good to solve them because you will get used to for your entrance exams. In those entrance exams you have to solve big lengthy problems in short time, so this will give you practice for them also. But fifth problem is a small one. We have the relationship VRMS is equal to V peak divided by root 2. Therefore V peak value is equal to Vrms into root 2. We all know root 2 value 1.414. They have given 300 as the voltage. So 300 into 1.414. Once you multiply it, you will get 424.2 volts. So here 424 volts is given in C. So the option is C. So that is the fifth problem. Then it's a simple problem. Then go to the sixth problem now. Now in the sixth problem, you can see two parallel plate capacitors X and Y have the same area of plates and the same separation between the plates. That means, so what they have given, two capacitors are there, C1 and C2. Both of them have area is same and distance between the plates is same. Area is same, distance between the plates is also same for both of them. But what is the difference? The first capacitor is X, second capacitor is Y. X has air between the plates and Y has a dielectric constant, slab. It has a slab with dielectric constant 2. Okay. So X has air, but Y has a slab, dielectric slab with a constant 2 between its plates. They are connected in series now. These C1 and C2 are connected in series to a battery of 12 volts. So that means these two, C1 and C2, this is C1 and C2, they are connected to a battery of 12 volts. Like this. C1 has air in between them, but C2 has this one between that is dielectric with a constant of 2. Then after that, the ratio of electrostatic energy stored in X and Y. So that is what they have given. We have to find the ratio of electrostatic energy. Okay, now let us see. C1 is equal to epsilon naught A by D. But C2 is equal to K epsilon naught A by D because its capacitance increases by K times. But if you see this epsilon naught A by D, it is nothing but C1. Therefore, C2 is equal to KC1. C2 is equal to KC1. Now, we have different formulas for energy. We can use any one according to the particular situation. In this particular one, I have taken the formula, energy formula, U is equal to Q square by 2C I have taken. For the first one, for the capacitor one, it is U1 is equal to Q square by 2C1. For the second one, Q2 is equal to Q square by 2C2, Q square by 2C2. Now, why I have taken Q as same? Because capacitors are in series. When they are in series, same charge flows through them. Now, what is the problem they have asked? Find the ratio of their energies. Therefore, we can take U1 by U2, or you can also take them as E1 by E2. Nothing is wrong if you use any letter. We want only the answer now. Q square by 2C1 divided by Q square by 2C2. So here you can cancel Q square and Q square, 2 and 2 you can cancel now. So you will get now C2 by C1, C2 by C1, just a minute, it's not C square, it's a C2 by C1. But we got here C2 is equal to KC1. So the KC1 by C1. So that is what we got now. But what is the value of K? The value of K they have given in the problem as 2. Okay. So now let us take the value as 2. Then you will get now that is U1 by U2 is equal to KC1 by C1. C1 gets cancelled. Now it is a K by 1, that is 2 by 1. So the ratio of the energies U1 is to U2 is equal to 2 is to 1. That is the answer. Now let's see where is that option. It is in option C. So our answer is option C, that is 2 is to 1. Okay. Now after that, let's continue. and go to the next problem, that is the seventh problem. An AC generator consists of a coil of 100 turns and a cross-sectional area 3 meters square. Okay, I will write whatever they have given. They have given the number of turns is equal to 100 turns, cross-sectional area is equal to 3 meters square, and it is rotating at a constant angular speed, that is omega is equal to 60 radians per second. 60 radians per second in a uniform magnetic field, that is B is equal to 0.04 Tesla. The resistance of the coil is 500 ohms. That is what they have given. What is the maximum current drawn from the generator? So they have asked the maximum current drawn from the generator is. Now we all know the formula for maximum EMF. We all know the maximum EMF, E naught is equal to NBA omega. NBA omega. Okay. So now that is N is 100, B is 0.04, A 3 and omega that is 60. Now with these two zeros, these two decimal points can be cancelled. It will become 4 into 3 into 60. Yes. 4 into 3 is 12 into 60, that is nothing but 12 into 6, 720 volts. Now the problem is what is the maximum current? So maximum current I naught is equal to E naught by R, that is 720 divided by R value they have given as 500, therefore divided by 500. Once you simplify, you will get the answer, that is equal to 1.44 amps. Now let's see where is this answer. This answer is in B. This answer is in B. That is 1.44. Sorry. That is 1.44 amps. So answer is B. Okay. So now let's go for the next problem, eighth problem. A sinusoidal voltage of peak value 283 volts and frequency 50 hertz. Peak value, that let us take, yes, I'll go back to the eighth problem. A sinusoidal voltage of peak value 283 volts, that is 283 volts, let us write V naught is equal to 283 volts, and frequency nu is equal to 50 hertz. It is applied to a LCR circuit where R is equal to 3 ohms, L is equal to 25.48 millihenry. Here it is a mistake, millihenry. It is not MPH, it is M and H millihenry, and MH millihenry, and C is equal to 796 microfarad. Then what is the power dissipated at the resonance? The point here is at the resonance. So that is the point they have given. Okay. So they have given the point that is at resonance. So let us take at resonance. What happens now? We all know XL is equal to XC. Okay. Then in that case, what is the power now? That is the question now. Let us take the current first, that is I is equal to, that they have given peak voltage, that is 283 they have given. I is equal to I peak value, or we will also take it as I naught by root 2, that is equal to let us say 1 by root 2, but I naught is equal to V naught by R, that is 1 by root 2. V naught means 283, R value is 3. So this is first we are calculating the value of current now. Then after that we will get now I is equal to 1 by root 2, 283 by 3. Actually I have taken directly V naught by R. I could have solved separately, but because of time problem, V naught by R, that gives you the peak value of the current, then divide it with root 2, you will get the RMS value of the current. Then you will get I is equal to, once you simplify, 66.7 amps you will get. Then power is equal to I square R, this is equal to 66.7 whole square into R, that is 3. Then once you simplify, you will get 13.35 into 10 to the power of 3, that is watts. You can also do it in some other way. You can also use different formulas we have. P is equal to V square by R also you can use. So whatever you do, you will get the P value as that is 13.35 10 to the power of 3, that means it kilowatts. Now if you go up and see what are the options here. Option A 39.7, option B 26, option C 13.35, D is 0. So option C has 13.35 kilowatts. So this will be the answer. 13.35 is the answer. Now let's go for the next problem. In Young's double slit experiment, if the monochromatic source of yellow light is replaced by red light, the fringe width increases, decreases, remains unchanged, or disappears. So that is the question now. It is a very simple problem. We all know very well fringe width, that is from Young's double slit experiment. We all know beta is equal to lambda d by d. Here we all know that is fringe width beta is directly proportional to the wavelength, but wavelength of red is greater than wavelength of yellow. So in this case, what happens now? If beta is directly proportional to lambda, then when you use red light, it will be greater than when you use yellow light. So what happens now? Fringe width increases. So now let's see the answer. Where is the answer now? Here if you see, answer is in A, increases. So the answer for this problem is A. It is fringe width increases. Now let's go for the next and the last problem for this video. 10th problem. Maximum kinetic energy EK of a photoelectron varies with the frequency of the incident radiation as. So let us see what are these graphs. Graph A, graph B, graph C. In all those graphs, they have given x-axis, they have taken frequency, y-axis they have taken energy. So we all know very well, that is we know very well, in the photoelectric effect, the frequency should be greater than a certain minimum value. We call it as the threshold frequency. Therefore, energy of these electrons, it depends upon the frequency. If frequency is less than a certain minimum value, electrons will not come out of the metal surface. Therefore, that energy, the electrons will take the energy from the photons and they will come out. This energy works for two things. First thing is, it will pull out the electrons from the metal surface. That's what we call it as work function. And the second thing is, it will impart kinetic energy for the electrons. So according to these four figures, if you see, D is the right option, where that is energy is directly proportional to that is frequency. Okay, so now if you see these four figures, this fourth figure is suitable for this particular one, because that energy should frequency should be greater than a certain minimum value, that is the threshold frequency. Then only electrons will come out of the metal surface. Okay, here I have solved 10 problems, 10 numericals. Okay, so now please go through them, and all the best for your examination. I wish you all great success in the coming examination and also in the coming CBSE exams as well as competitive exams. These numericals will be very helpful to you in the all coming examinations. All the best. God bless you all. Do well and excel in your studies and get wonderful marks. God bless you all. Bye. We will meet with another video. Okay, we will meet in the next video with another topic. Bye. God bless you all.